Welcome back, folks. In today's class, I'll take some math problem on the inclined plane equations. And this question is given to us. The 3.5 kg block is sliding down an inclined plane at an angle of 15 degrees. The surface of the incline exerts a force of kinetic friction of a magnitude of 3.9 Newton. Calculate the acceleration of the block. So there's a 3.5 kg block which is placed on an inclined plane, and the inclination is 15 degrees. And what else is given to us? There is a 3.9 Newton force, kinetic frictional force, which is acting onto it. So frictional force will be in the opposite direction because it is sliding down. So the frictional force will be upwards. And we wanted to find out that what is the acceleration of the block. That's what we are looking for. So the equation I'm going to write is F net is equal to force applied and plus minus force of friction minus mg sine theta. So this is the standard equation which we've learned. We're going to first of all write that equation, and then we will try to eliminate the terms which are not there. So we wanted to calculate the acceleration, so net force will be equal to ma, that's for sure. Is there any applied force on this block? Means, if are we applying any force purposefully? No, there is only gravitational force which is acting, because of which the object is trying to slide downwards. So then what we're gonna say in this scenario, uh, that applied force is equal to 0, and force of friction will be equal to uh, is equal to mu mg cos theta. Why? Because coefficient of friction, is the coefficient of friction given to us? No. So I mean, the coefficient of friction is not given to us, so we won't use mu mg cos theta. Rather, we will use the force of friction value. So force of friction given to us is directly 3.9 newtons. 3.9. If the coefficient of friction was given to us, then I would have converted it to mu mg cos theta. All right. Now I'll just directly put the positive 3.9. Why positive? Because this is acting in the upward direction. Minus mg sine theta. Mass value is 3.5 kgs multiplied by 9.81 multiplied by sine of 15 degrees. Okay. And then up here also, I can change the mass to 3.5 kgs. So this is 3.5 down here. That is the mass, and I'm looking for the acceleration. So once you're going to solve this, this is 3.9 minus, if I were to do the math on my calculator, this will come out to be 3.5 multiplied by 9.81 multiplied by sine 15. Again, make sure your calculators are in the degree modes. So this is 8.86. Let me just check whether my calculator was in degree modes or not. Yes, it is in degree. And then 8.886, 8.886 minus 3.9, which is 4.986, but this is a bigger number, so I'll keep the sign convention. Whatever the sign with this bigger number is, that's what I will retain. 3.5a and 3.5a, and dividing both sides by 3.5, 3.5, and then we will get the final number. So this number divided by 3.5, which is 1.4 approximately. So acceleration comes out to be 1.4 meters per second square. So I guess this gives you a brief idea how you can approach the questions when you are given the force questions with the reference to the inclined plane. Let's take another example of when the object is placed on an inclined plane. So here it is. So a 50 kg toboggan on a snowy field hill. The hill forms an angle of 20 degrees with the horizontal, and we are not given any figure. We will draw a figure in this scenario, and the coefficient of static friction, that's what we are looking for, coefficient of static friction. Now there is a new term which is involved, static, this word. So first of all, let me tell you what's a static friction is. There are two things. One is kinetic friction, another is static friction. So if this is a block, which I'm trying to push in the forward direction. So before the blocks just starts moving, the force which I'm applying, because of that force, whatever the frictional force which is being produced to resist the motion, that's called static frictional force. And the coefficient of friction which will be involved with that will be static coefficient of friction. Okay, if the object is moving, once the object starts moving, at that time there is a frictional force also which is acting in the opposite direction. At that time, the frictional force which is acting is the kinetic force of friction, and the coefficient of friction will be the kinetic coefficient of friction. So hopefully you were able to understand what is static. Static means object is not moving or about to move. Both are considered as static. If the object is moving, then we will consider the kinetic coefficient of friction. Both values are different. And once you're gonna look into the tables also, you will find that kinetic coefficient of friction is totally different from static coefficient of friction. Kinetic coefficient of friction, mu k, will always be less than mu s. Remember this thing. You can also think about this when you are trying to push a sofa in your home. So what it is very hard to start make it is hard to make it move to begin with. Once the object starts moving, let's say you're pushing the sofa or the couch, and once that sofa or couch starts moving in the forward direction, at that time it becomes relatively easier for you to push it in the forward direction. But the initial push is always the toughest. And that is because mu s is always greater than mu k. All right. Now let's look into this question. So I'm going to draw the diagram for this question. The diagram will look like this. So this is the diagram. This is the toboggan. Okay. Okay. Let me change the color for the toboggan. And this makes an inclination of 20 degrees. Theta given to us is 20 degrees. And this is moving down the hill. Toboggan, let me re-look into the question. 50 kg toboggan on a snowy hill forms an angle 20 degrees, and toboggan begins to slide. Begins to slide means I will consider the static, right? Begins or about to, that means you have to consider the static coefficient of friction down the hill, and calculate the coefficient of static friction. Coefficient of static friction, mu, is what we are looking for. 50 kg is the mass for the toboggan. Again, I will rewrite the equation. F net is equal to force applied plus minus force of friction minus mg sine theta. Again, it begins to slide because of its own weight. There is no applied force, so I'll consider this one as 0. And then force of friction will act in the opposite direction because toboggan begins to slide in the downward direction because of mg sine theta, which is causing it to move downwards. And you can conduct an experiment if you are confused with this. Or if you place a book on a table, then slowly but surely move this table at an inclined plane. So you can move it like this, and you will find after a certain time this book will start moving downwards because of gravity. So that value is mg sine theta. All right. And now coming back to the question, this force of friction value, we wanted to find the coefficient of friction. So I'll write it as mu mg cos theta, and this will be upward force of friction, and minus mg sine theta. And it begins to slide means we will, as I said, we'll consider it rest. That's why we're trying to find out the static for coefficient of friction also. And net force will be 0. At rest, acceleration is 0. F net is equal to mass times acceleration, and this is 0. Thus, net force is 0. And now we will just rearrange the equation. This is mg sine theta equal to mu s mg cos theta. And I can cancel out the mu mg and mg on both sides. Sine theta equal to mu s cos theta. Okay, I mean, if you have the calculator, you can put in the values and then divide. Go ahead and do that. Otherwise, I can keep on solving this, I can divide by cos theta and cos theta. Once you divide sine theta with cos theta, that comes out to be tangent theta. Okay. If you don't know how did I get to this tangent theta, you can just put in the number of sine of 15 degrees equal to mu cos of 15 degrees and solve it simply. That's going to give you the answer too. So mu s, and tangent of 15 degrees equal to mu s, and then tangent of well, is it 15 or 20 degrees? It is 20. So don't use 15, use 20 here. So I'm going to use the 20 down here also. So tangent 20, the value comes out to be 0.36 equal to mu s. So again, we were able to find out the coefficient of friction by applying this technique. One thing you will find, the mass of the toboggan was given to us in this question. Now, if we didn't end up using the mass. So what does this tell you? Even if the mass was not given to you in the equation, we could have still solved it. So that's you need to remember. So how to maneuver around the terms. So I didn't use the mass value in this question. So hopefully you understood these questions, and I'll see you with another video. Till then, bye now. And if you want to subscribe the channel, that'll be much appreciated. And enjoy the rest of